Hi everybody. I'm pretty sure everybody really had kind of like difficulty to understand Vernier principle. That's normal. Even the same thing happened to me when I was doing A level because that was the first time I listened to that one. I heard that. Remember one thing, I'm not just discriminating about their job, it's a really good job, but regular technicians, like normal technicians you see in those garages, they also know how to mess up. So from the practice, but they most of them don't know about the further application of it with the scientific applications. So here we are going to go for deep concept of and about to make our own Vernier scale. Even we have to gain that much of knowledge. So let's pay attention to why. Firstly, there was a requirement of a Vernier scale arise. Okay, like of the previous video, I'm going to finish this within like 10 minutes. So for the meter ruler, consisting 1 millimeter as the smallest tip. Please count. Please count is 1 millimeter. Right. I told you from a millimeter scale, that it's a meter ruler, under the maximum tolerance of 1%, the minimum reading will be 10 centimeter. Okay. In our O-level life and earlier, we used to measure smaller distances like 5 centimeter, 3 centimeter, 4 centimeter, etc., etc. But the problem was, it is really, we were not doing very high scientific things. As I told you in the examples, I told you about how precision it should be maintained and how accurate it should be. The Donald Trump's example, and it actually happened. Okay, so it is going to change the direction a lot if you make simple displacement. So that was a very simple example, but for very complicated scientific experiments, you can't make technically any error. So somehow you have a margin of error 1%, right? So if you want to measure anything lower than 9 um, centimeters, sorry, 10 centimeters, somewhere like 5, 6, 7, 8. So you should have to have very lower least count because the 1% margin will be remaining there. I wrote in the wrong position. 1% error margin will be the same way, and the least count and the minimum reading and the 100%. These are the percentage error constituents. This is constant. This is constant. You have to reduce here. That means you have to reduce the least count of the meter ruler. It is impossible because if you divide 1 millimeter into further parts, it is not easy to read. It is actually unreadable. Right. So how can you read something? So for a single scale, it is no longer applicable. So we have to go for something new. So that's why scientists called Vernier found out the way of having two different scales, right? Two different scales. One is the main scale. The other one is the Vernier scale. Now, firstly, I just gave you a definition of what is Vernier scale. These things are unlikely to ask, but try to read and remember. But I will explain you Vernier scale in a very, very, very similar manner, simple manner. Okay, okay, not like the mathematical model because I realize that if I explain everything in mathematical model first, some students can't understand. Firstly, I'm just going to go for numerical method and let you understand what is Vernier scale. Then go for the bigger mathematical scale. Okay, have a good look. Firstly, pay attention to the regular Vernier scale. I'm firstly starting with the regular Vernier scale. In the regular Vernier scale, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. You choose, actually, he chose 9 millimeter length from the main scale. And he divided this 9 millimeter into 10 small parts. 10 parts. This is getting closer to here, very closer. Finally, here. Now see, okay, 10 parts. So you can easily understand. Now you divide what? Length of 9 millimeter into 10 parts. So what is the length of one part of vernier? VSD. It is called vernier scale division. It is very easy. Your total length was 9 millimeter. Your total length was 9 millimeter. So you divide it into 10 equal parts. So one vernier scale division is 0.9 millimeter. As I show you in the last week, this is slidable. I'm going to show you that again. Have a good look at. So the main scale and the vernier scale. So vernier scale is slidable. You can see there is a very small gap. That is the least count. I will explain you why. So see, you can move this along. I'm pretty sure all of you received your own vernier caliper now because I sent to you. According to the vernier caliper, have a good look at. This is the one you may have received already. So this is the vernier scale. You can slide it on the main scale like this. So it is a slidable scale, right? Right. How do you do that now? Now there is a gap between the first line of the vernier scale and the first line of the main scale. Now have a good look at this gap. There is a very small gap. Delta X difference. That is 1 millimeter from the main scale minus this length 0.9 millimeter. Now it is going to be least count of the vernier caliper is going to be 1 millimeter minus 0.9. So the least count of the instrument is going to be a regular vernier scale 0.1 millimeter. This is the basic thing you need to know about vernier scale. I will teach you right from the beginning with numerical examples before going for algebraical examples in the first of next class with full examples and doing all and finish the entire vernier caliper and with the exam questions. Don't worry. I will explain you everything until to the every single student to understand. No worries because I will go along with very simple exam, right? To the A-level questions. Okay, get ready for tomorrow's class. This is all about the very basic of vernier caliper. And I explained you something about reading. I will explain you that again in that class, how the reading will proceed. Nothing to worry about. Okay. I hope you understood what is the simple vernier scale, regular vernier scale. It's essential to understand the regular vernier scale. Then we can go for extended vernier scale and everything. Okay. So let me show you another one. Now the scale is just kind of like damaged here. I have to rescale it. This is called spectrometer. It has a certain circular vernier scale. We are going to discuss all of these. Okay, right. Let's finish this video and get ready for tomorrow's class.